Good day. So for this video, I'll be presenting chi-square. So chi-square is another formula or function that is used in inferential statistics. So technically, I'll be presenting what is chi-square, when it should be used, and how it should be used. Okay, so chi-square is also known as cross-tabulation, especially when you will be using the SPSS software. So chi-square is used as a test of significance when both variables are categorical that are expressed in frequencies. So technically, your independent variable and as well with your dependent variable are categorical. So simply, they are nominal in nature. However, nominal or ordinal. However, although categorical, in some literatures, qualitative yung chi-square natin, it is still quantitative in the sense your variables are expressed through frequencies. So I assume you already know frequencies. So basically, it is just counting. Okay. So there are actually three formulas. Tatlo. There are actually three formulas in chi-square. However, I'll just present to you the two. Although these are the common formulas, the two formulas which is widely used in social sciences, no. So we have chi-square test of homogeneity, then chi-square test of independence. Now, why I need to present this two, no? Because it has something to do when we construct our hypothesis. Okay, so when it comes with the formula, the test of homogeneity and the test of independence uses the same formula. However, sa independence, we use POSOC analysis if needed. So, I might present it through SPSS na lang, no? Although, I'll present the manual computation for your chi-square. Now, on your hypothesis, this is where now your homogeneity and independence differ. Okay, we use test of homogeneity when we craft our hypothesis or we want to know the relationship or we want to test if there is a significant relationship when we look into homogeneity. So it's very similar with regression or rather correlation. So yeah, okay. Now for your chi-square test of independence, we use this one or we will be using this one if we wanted to know or we wanted to know or determine the significant difference, just like ANOVA then t-test. Now, please take note, this is not an exact word coming from a statistician, but pag sinasabi natin correlation, relationship, para siyang correlation, no? Walang causality. Unlike dito sa significant difference, there's already a causal, not just a causal, or rather, hindi lang comparison, kundi causal comparative. So, may causality dito, no? Another feature about your chi-square, we only use chi-square when we represent chi-square through the distribution curve. Right tail lang siya or right skew, no? So, technically, nandito siya. So, we assume all of our chi-square should be positive. So, that's it. So, this is an example of your chi-square test of independence. So, going back dun sa video, di ba? We use independence just like correlation, significant relationship yung gagamitin nating phrase sa hypothesis. While pag homogeneity, we now use significant difference. Okay, so mas madali natin maintindihan yung interplay ng variables by looking into a case or example, no? So in this exercise, so this is extracted from your handouts. A study was conducted to know if hypertension is independent of the drinking habits among 200 respondents. Is independent towards the drinking habits. Wrong grammar, okay? Hindi naman tayo English major, no? Yun, no? So, more likely, independent variable natin is drinking habits. Does it affect hypertension levels, no? So, IV natin, presume effect, drinking habits natin, no? Tapos, your dependent variable is the level of your blood pressure, hypertension. Okay, so look, from your from your variables, both your IV and DV should be categorical. So technically, nominal or ordinal siya, no? So look, when you try to check, yung independent variable natin is categorized into ordinal, no? So from non-drinkers, So, pwede siyang gawing range, kunyari 0 to 12 bottles. Moderate drinkers, 13 bottles to 100 bottles. Then heavy drinkers, 100 bottles and above. Although, made up lang naman yung range, no? So, yun, no? So, nagiging ordinal siya. Then, this one would now be nominal. Hypertensive, then non-hypertensive. So, ganun yung ano natin, no? So, nominal at nominal. And looking from your chi-square, di ba? Ang isang term sa chi-square is cross-tabulation. So, cross-tabulation. This is the table. Then, we cross each tables now. Okay. Now, paano ma-compute yan? Ganito. These are given. So, they are expressed through frequencies. Sinabi kanina dun sa unang presentation. So, chi-squares are expressed through frequency. So, there are 20 non-drinkers who are also hypertensive. 40 moderate drinkers who are also hypertensive. So, binibilang lang natin yung mga respondents, no? So, total of 200 respondents, tapos dinistribute na lang natin according dun kung saan sila nabibilang, no? Okay. Now, first thing, ito yung given ulit. Now, bakit may mga ganito? Okay. Here's the step in your chi-square. Wala pa yung mga to, Ito lang yung given. First is you find your FO stands for your observed frequency. Paano tong observed frequency? May use first cell number 1. So, cell number 1, 2, 3, 4, 5, 6. So, cell number 1, no? Okay. Yung observed frequency natin is 20. Ano yung nawawala? Let's go to the letter B na muna, no? So, yung FE. So, we have to find the blue one, which is FE. FE. FE stands for express frequency. Now, your express frequency is equal to yung total nito, yung total nitong column, itong column na to, which saan nabibilang yung 20. I hope na-get mo yung 69. So, yung 69 times yung row na kung saan nanggagaling yung first cell. So, 69, kasi nandito yung 20, multiply them, divided by 200. So, I hope you get it, no? So, technically, makukuha natin is 40.02. That is for cell 1. Now, to give you an example for cell 2, ganito naman, no? So, nasa red pa lang tayo, yung observed frequency, yung FO. Saan nakuha itong 35.96? We now multiply 62 times 116 divided by 200. Doon natin nakuha yung 35.96. Now, kunyari itong 26.04, saan natin nakuha yan? 62 times 84 divided by 200. Okay. So, lahat ng red, gagawin muna natin yan. Okay. Now, after nakuha natin yan, we now proceed with letter V. We will now compute for the individual computed value ng chi-square. Now, paano to? Paano to? Okay. First things first, no? Let's, para organize, let's do it per cell. So, ano natin yung cell na to? Nahanap na natin. Nahanap pa lang natin to. Okay, so hanapin pa lang natin yung blue. Hanapin pa lang natin yung blue. Given na ito, yung observed at yung expected. So, from your cell number 1, 20. Gayahin natin itong formula. 20 minus 40.02 divided by 40.02. So, pag na-compute natin yan, makukuha ngayon natin yung color blue, which is now, or yung individual chi-square, which is now 10.02. Yun yung blue. For cell number 2, ganoon naman din. Cell number 2, this is cell number 2. 42 minus 35.96. Ito yun, yung E, divided by 35.96. So, 1.01. Okay. May proceed with the third cell na lang para medyo magets natin. So, ito yung observe, FO, 54, minus, we get your expected frequency, FE, 40.02 square divided by 40.02. Kaya 4.88. Tapos yan. Okay. Now, jump directly. Let's go with cell number 6. Nakuha natin lahat. We could immediately compute for your computed value for your chi-square. So, this is actually chi-square. Forgot that one. So, i-add lang natin. Paano natin siya i-add? I-add natin to, at to. Or rather, i-add natin to, at to. So, pag in-add natin lahat ito, ang sagot natin dyan is 37.88. We now proceed with hypothesis testing, no? So number one, you craft your hypothesis as well. Test of independence tayo. We just want to know if independent nga ba, kung may causality. So no significant relationship between hypertension and drinking habits. This is drinking habits. Then alternative hypothesis, there is a significant difference. There's a significant difference between hypertension and drinking habits. Okay, we use yung alpha natin 0.05. Now for your degree of freedom sa chi-square, ganito siya, no? Okay, C stands for columns. Ilan yung columns natin? 1, 2, 3. Ilan yung rows natin? 1, 2. So more likely we also look into the groupings, kung ilan yung groupings, no? So minus 1, kuha natin yung 2. Okay, the fourth process, nakuha natin yung computed value ng chi-square, which is 37.88. Okay, now we will be doing, alamin na natin kung anong hypothesis, no? No need to put yung ganun. I forget again the term, no? So given na to, we need to find for the tabulated value of your chi-square. I'll be inserting a video. Okay, so na-compute ngayon natin yung chi-square computed value natin. So ngayon hanapin ngayon natin yung chi-square tabulated value natin or your x squared TV. Okay, so different table na naman ang ginamit ko. So always take note if you do the manual computation, iba sa t-test, iba sa ANOVA, iba sa chi-square. Okay, so technically you could just search on the internet. So ito yung table. Okay, so two values are already given. So yung degree of freedom natin. So previously na-compute natin siya. Now 2 yung lumabas na DF natin. Then your level of significance, ang level of significance natin always would now be 0.05. So simply align ang lumabas na ang lumabas na x TV natin, x squared tabulated value is 5.99. Now after that one, so nandiyan na yung 5.99, then we now compare. Mas malaki yung computed value natin. Now by principle, always remember, pag mas malaki yung computed value natin, we now reject HO, we reject the null hypothesis, then we accept your alternative hypothesis. Simply, ang gustong sabihin is that there is a significant difference. That there is a significant difference among your groups. So you could provide this conclusion, no? So this is not pol-sci related, but I think this is the most simpler way. So the more you drink from your range, diba? The higher the chances you suffer from hypertension. When you also look into your conclusion, para siyang correlation, diba? So ganyan siya, no? So I hope this will give us a lesson, but this is just a joke, diba? The more you drink, the more happy, diba?